So let's look at chemical bonding. And chemical bonding is really just the force that actually holds atoms together to form compounds. So every time we have a compound, what's keeping them together, the glue, if you will, that is keeping those together is a chemical bond. And these chemical bonds actually come in two forms. They are either ionic or covalent. And we're going to spend some time looking at the difference between an ionic and a covalent bonds, but the two types of chemical bonds. Well, let's look at the first one. And the first one is a ionic bond, and what makes it ionic is it's a metal and a non-metal element forming a bond. So in this type of bond, the electrons transfer from one element to the other. And that is what makes this bond so unique. It is a transfer of electrons. If you look at your periodic table, a metal is a positive and a nonmetal is a negative. So we have a strong attraction of oppositely charged ions. These positive and negative elements are actually going to be attracted to one another because they are oppositely charged ions. So let's use this as an example. We have calcium and fluorine, CaF2. Now, what's happening down at the molecular level is this. Calcium has a charge of 2+, which means it has 2 extra electrons. 2 electrons that it's willing to transfer to something else. Up here, we have a -1 and a -1 on the fluorine, and they would like to attract an electron. They need an electron. And so what happens is the calcium actually transfers its an electron from one to the other, like so. And now if we look at the outer shell of each of these elements, there are a full number in the outer shell. There's 8. There's 2, 4, 6, 8. And this outer shell is right here. 2, 4, 6, 8. And those now have full valence shells, full outer shells, and they become stable. So what's actually happening here is calcium gives up 2 electrons to each of the fluorine ions. The fluorine ions get the electrons transferred. Now calcium, because it is a 2+ on the periodic table, it's attracted to 2 of the F- ions. The thing to note here, we have to be very careful of this, is that the electrons that calcium loses are equal to the electrons that fluorine gains. So the electrons lost are always equal to the electrons gained. And that's one of the major properties of an ionic bond, a transfer of electrons. Well, this is different than a covalent bond. And a covalent bond doesn't transfer, but shares electrons, shares valence electrons. So no electrons move. And what makes a molecular compound different is now it forms a molecule. The molecular compound forms from a molecule, and the molecular compound is actually between 2 non-metals. So 2 non-metals can form a bond. They don't have to have opposite charges. So here's an example. We already know CO2, carbon dioxide. What's happening in carbon dioxide? If we can see here, the yellow electrons from carbon are actually going to be shared with the blue electrons from oxygen. And if we just look at this piece right here, there's 4 electrons, 2 from oxygen, 2 from carbon, that are being shared in the outer shell. And the same applies over here. There's a sharing in the outer shell. And so if we count all of the oxygen electrons in the outer shell, there's 1, 2, 3, 4, and 4 from the sharing for a total of 8. Carbon, 1, 2 in that first shell, and the outer shell has 4 shared here, 4 shared here, and oxygen, 1, 2, 3, 4, plus the 4 shared. And the valence electrons are shared, and the shells are filled. And this is what forms a stable covalent bond. Now, this allows us to explain our diatomic molecules. And if you remember, diatomic molecules we talked about earlier on, these diatomic molecules actually pair up and have full orbitals. They are those magic 7 on the periodic table. So remember on your periodic table, those magic 7, but they're actually forming a pair with themselves. So just like before, the diatomic molecules have 4 electrons here that are shared. They count as 4 electrons on the outer shell of each of the oxygen, and that's how we have diatomic molecules. Well, let's look at some of these properties, because an ionic compound and a covalent compound have unique properties. Well, first one, ionic compound, very, very strong bond. If an ionic compound is formed, it doesn't really want to come apart. Reason for that is we have alternating positive and negative ions. So in this picture down here, the green are the negative and the gray ones are the positive, and notice we have this positive, negative, positive, negative. So as a result, they don't want to pull apart, they want to stay together. This positive negative forms a shape. So if we were to look at this under a microscope or look closer at this, we would actually see this definite crystal shape, positive negative, much like that picture. Ionic compounds have a very, very high melting point. They don't want to come apart. It requires a lot of energy for them to change state, so they stay in their crystal form. Same thing applies to boiling points. Now, because they do form this crystal, they aren't likely to bend. They're very, very hard. But if we were to try and bend these, they would just snap. They're very brittle. They don't want to bend. They don't want to move at all. They're very, very hard. But if they did move, they would be brittle and fall apart. And if we were to take an ionic compound, put it in some water, stir it up, we would see that it would actually conduct electricity. And this electricity test is what we can do to test if we have an ionic compound or not. Now, when you're trying to remember the different types of properties, often we remember one and the other is the opposite. So, molecular compounds, also known as covalent compounds. Well, first of all, their shapes aren't a definite shape, they're variable shapes. They come in different shapes and sizes. They don't have that positive, negative, definite shape. Melting point, very, very low melting point. Covalent bonds, we can get those apart pretty easily. Just add some water. Covalent bonds, we can get those apart pretty easily. Just add some heat, add some energy, and we can melt them and boil them. Also, a covalent bond, if we were to dissolve it in water, it does not separate into ions, it does not conduct electricity. So very, very important there. Basically, the opposite of ionic compounds are covalent compound properties. Well, now we've looked at different substances. Let's put it all together. Because we started out with these substances, an element from the periodic table, and if we remember from the periodic table, an element, if we just have the element, it is an atom. So an atom of gold, an atom of silver. The one we introduced today, an ionic compound, at its smallest level, the smallest particle of an ionic compound is an ion, one of those charged particles. And the smallest particle of a covalent compound is a molecule. And so we have 3 different substances, 3 different smallest particles, And we're going to spend some time looking at these smallest particles as we get deeper into the course.